Assalamu alaikum. My name is Ahtisham Asghar. My registration number is 2018 CS248. Today I am discussing about calorific value of coal using equipment in research lab. First we define calorific value. Calorific value is a measure of the amount of energy produced from a unit weight of coal when it is combusted in oxygen. Importance of calorific value. The calorific value of coal is measured from almost all coal samples. It is a measure of the heating ability of coal and is needed to estimate the amount of coal needed to produce a desired amount of heat. Calorific values are also used to define coal rank in low and medium rank coals below the rank of medium volatile bituminous in the US classification system. Types of calorific value. There are two types of calorific value. First, high calorific values या gross calorific values. HCV and GCV, it is the abbreviation of both two types. Low calorific values या net calorific values. Then gross calorific values. This topic discussed by my other group members. So thank you. Allah Hafiz.
Assalamu alaikum. My name is Muhammad Ayub Abbasi. Today our topic of presentation is calorific value of coal using equipment in research lab. So I will start from the types of calorific value. There are two types, basically a high calorific value and low calorific value. High value is also called as gross calorific value, and low value is also called as net calorific value. So gross calorific value is so that it is the amount of heat generated when a unit quantity of fuel is completely burnt in oxygen and the products of combustion are cooled down to the room temperature. Net calorific value is defined as the unit as the heat generated or heat produced when a unit quantity of fuel is completely burnt and the products of combustion are not allowed to escape. Whether we can see that in the gross calorific value, the products of combustion are cooled to the room temperature. So next we will see that how the calorific value is determined, or how we can determine the calorific value of any solid or non-volatile liquid. It is determined by using a bomb calorimeter. Bomb calorimeter is an instrument. It looks like this. It is shown its constant or its construction or its equipments are shown in this slide. We can see that this is the type of instrument which is used. After that, we will see the principle of what is the principle of measurement or determination of calorific value. Basically, calorimetry principle is used. The use of calorimeter or calorimetry principle is applied in this all. It is a known amount of fuel is burned in excess of oxygen and heat liberated is transferred to a known amount of water. So this is from my side.
Assalamu alaikum. My name is Muhammad Abu Bakar and my roll number is 2018CH236. So my portion for this presentation starts from how can we calculate the calorific value. The formula for the calculation of calorific value is 343.3 multiplied by percentage of fixed carbon plus A multiplied by percentage of volatile matter. Gaussian formula is unreliable for fuels having high percentage in oxygen. Moving on to next slide. How can we calculate the calorific value of coal? The procedure or formula for the calculation of calorific value is megajoule by kilogram equals to BTU by pound multiplied by 0.002326. For example, a coal with a calorific value of 14,000 BTU by pound has a metric calorific value of 32.56 megajoule per kilogram. We can find more information about this analysis at KGS Laboratory Services. So moving on to next slide, we have a comparison table between the fuel and their specific calorific values. At the top of the list, we have cow dung cake, and at bottom we have hydrogen. The list suggests the lowest value is of cow dung cake, then of wood, then of coal, then petrol, then kerosene, then diesel, methane, CNG, LPG, biogas, and the highest is for hydrogen, which is 1,50,000. Moving on to next slide, here is the chart which also indicates the calorific value in megajoule per kilogram. It is indicated by different color series, which starts from the lowest value to the highest calorific value. It suggests the lowest value is for wastewater, then comes the dried leaves and waste paper, then comes maize straw and waste paper, then coconut husk and waste paper, then bagasse and waste paper, then bagasse, sawdust and waste paper, and finally we have coal, which have the highest of them all, reading 28.47. Next slide is how can we increase the calorific value of coal? So the simplest way to increase the calorific value of coal sludge and flotation tailings is to lower their water and ash contents. The humidity of fine coal waste from current production is largely enhanced by the applied dewatering installations, where the filtration presses prove the most effective. My portion of this presentation ends here and the next part rests to Mr. Hasnain Kashif.
Hello, Assalamu alaikum. My name is Hasnain Kashif and my registration number is 2018CH216, and I'll be talking about how to measure talking about the procedure of measuring calorific value. So here's the procedure. Firstly, we use the bomb calorimeter with the given model was used to measure the cross calorific value of the solid and liquid samples. It is a constant volume type calorimeter that measures the heat of a particular reaction or measures the calorific value of the fuels. Bomb calorimeters are built in such a way that they can withstand the large pressure produced within a calorimeter due to the reaction or burning of fuel. And on the next we have the electrical energy is used as an ignition source for the burning of testing fuels. So here we use electrical energy to ignite the source for burning the testing fuels, and the heating filament is made up of tungsten materials which can be found in a lot of bulbs nowadays. The reaction takes place in a closed space known as the calorimeter proper, in controlled thermal contact with its surroundings, the jacket at constant temperature. The calorimeter proper is usually a metal can with a tightly fitting lid containing water, stirred continually, in which the bomb itself is situated. Then it consists of a sealed heavy-walled container in which the reactants are allowed to react under constant volume conditions, following the ignition of the combustible matter in an oxygen atmosphere. Then the gases at higher pressures are frequently used, hence the name. In 1878, Paul Weil developed the first bomb calorimeter, which was used for measuring heats of explosion at the French Service of Explosives in Paris. Now, talking about precautions, we have that first we have to submerge the bomb in the calorimeter bucket. Then we should avoid the tilting of the bomb because make sure that there are no persistent gas bubbles escaping from the bomb seal. If you see gas escaping, then please do not continue as it could be hazardous. Thank you.